In this video, we're going to talk about probability distribution. So the first thing we need to know about probability distribution is that we're going to be representing all the outcomes and pairing them with their respective probabilities. This can be used with either discrete or continuous data. An example of discrete random variable, as we know discrete are usually whole numbers. So one of the probability distributions we're going to be looking at for discrete numbers is with the binomial distribution. So we're going to see that in the next couple of classes to come. And another probability distribution we're going to be looking at with continuous data this time is called the normal distribution. In today's video, we're not going to focus on binomial or normal. We're just going to focus on introducing ourselves to what is a probability distribution and doing a couple of questions with that. These are the key learning concepts for this video. We have to remember that all our probabilities must add up to 1. We're going to be calculating what's called the expected value. The expected value is going to be the sum of all the outcomes multiplied by their probability. And then in our last examples, we're going to see how do we determine if a game is fair or not. So let's look at an example. Imagine you have this spinner here. You have 4 different sections, A, B, C, and D. In green, you have the amount of money you would get when you're rolling on one of these sections. So if you fall on A, you would get $2, on B 4, C 7, and D 1. In black, that's the probability of falling on these sections. So as you see, we have a circle. A represents half of our circle, so we have a half chance of falling on A, while B, C, and D are 1/6 each of our circle. What we're going to be doing is we're going to be talking about the outcome of this spinner, and we're going to be pairing it with their probabilities. So the outcome of the spinner, what we're going to be doing is creating this table. This table has the outcomes on the top row. So X, our outcomes are the number of dollars that we can get. And then we're going to pair that with the probability. So this is the probability of getting each of the outcomes. So as you see, our $1, which was in section D, is 1/6 the probability, while $2, which was section A, has a half. Notice that this line of probabilities, if you add all of them together, must add up to 1. So this is what we're going to be doing. We're going to be looking at problems and creating what's called a probability distribution table and answering many questions with that. Okay, let's take example 1 for today. Find the value of k when the random variable x is described by the probability distribution shown in table 2. So what you're noticing here is we have the probability distribution x with unknown value k. So in this situation, we have 5 different possible outcomes from 0 all the way to 4. And the probability for each of the outcomes is described, and the only one we're missing is k. For this question, we have to use our first key concept, which is that probably adds up to 1. So you create an equation where all of the numbers for probably we see here, so equation 2 here, adds up to 1. In this situation, you can use your equation solver, so the numeric solve, and you have one side of the equation is 1, and the other side of the equation is adding up all our probabilities together. K must be labeled as x. And when you solve it, you get that k is equal to 0.2. So your final answer for example 1 would be 0.2. Next, let's talk about more in detail the expected value and what makes a fair game. So the expected value is also known as the mean. So this is kind of our long-term average of what we would expect if we would do this experiment many times, add up our outcomes, and then divide it by how many outcomes we have, right? So the long-term average is this expected value. And we're going to get this by multiplying the outcome by its probability and adding up all of that together. This equation is given to you in the formula booklet. Now, another key concept is fair game. So we say that a game which is not biased towards any player is considered fair. So a game in which a given player can always win by playing correctly if they're called unfair. So in other words, when you're looking at a fair game, we need to have kind of an equal opportunity for winning. And we're going to say that a fair game is happening when our expected mean is equal to 0. And we're going to need many examples to understand this concept. So let's look at the first example. At a school fair, you are given a number of tokens. In one stall at the fair, there is a spinner with 8 sections. If the spinner lands on red, you get 3 tokens. If you land on green, you get 5 tokens. If you land on any other sector, you lose 2 tokens. Is this game fair? The spinner in question is on the right hand side of the screen. So we see we have our different sections. Each section is divided in equal parts. So all of these represent 1/8. So the first thing we're going to do is we're going to build a probability distribution table to understand the different outcomes. Now, the different outcomes we have are winning 3 tokens, winning 5 tokens, or losing 2 tokens. So for this distribution, I have the 3 tokens, 5 tokens, and losing 2 tokens. The sign is very important, so make sure that you identify the winning with positive and losing with negative. Next, you identify what is the probability of each of these outcomes. Winning 3 only happens with red, which is 1 out of 8. Winning 5 only happens with green, which is 1 out of 8 as well. And then everything else is going to be losing 2, so that's 6 out of 8. To check you did this correctly, you can add up your probabilities, and they should always add up to 1. Now, is this game fair? Well, we first need to look at what is the expected value. So in order to calculate the expected value, we multiply each outcome by their probabilities, and we add those together. So adding up 3 times 1/8 plus 5 times 1/8 plus -2 times 6/8. We get an expected value, which is negative 0.5. So this means that on average, you're going to always lose half a token every time you play. So remember, this is a long-term average. So if you do this game 100 times and you add up all your tokens you won divided by the amount of 100, then you should on average always lose half a token. Now, this game would not be considered fair because if we're always expected to lose on average, well, that's not a good thing. So it would be fair if this number was equal to 0, but since it's not equal to 0, this is not a fair game. Okay, next example. A fair 6-sided dice with sides numbered 1, 0, 1, 2, 2, 5, and 6 is thrown once. What is the expected value to get? So the expected value, first let's build our probability distribution table. So we have the outcomes 1, 0, 2, 5, and 6. Now you have 2 choices for these. So I built 2 different probability distribution table. One where I put the value of 2 twice, but if we're doing this with proper mathematics, we should be combining these 2 together, and we have one time we have the outcome of 2, and then the probability changes to 2/6. So either you have always 1/6 here, or the proper way of doing it is that you combine where you have the same outcome 2, and then you have the probability of 2/6. And in order to know what is the expected value, well, we need to multiply each outcome by your probability. So again, if you're doing it with the first table, this is what your expected value should be. If you're doing it with the second one, then you should have the exact same outcome. So the long-term average here, the expected value is 2.67 if you round to 3 significant figures. Next example. A bag contains black and white chips. Rose pays $10 to play a game where she draws a chip from the bag. The following table gives the probability of choosing each color. So we have our 2 probabilities that add up to 1. Great. Rose gets no money if she draws a white chip, and she gets K amount of money if she draws a black chip. This game is fair. Find the value of K. Okay, I'm going to use the probabilities here and create a probability distribution table. So the first thing that we're going to look at is what is the outcomes. So we know the probabilities, and now let's talk about their outcomes. We're told that she pays $10 to play, and then she's going to get no money for the white chip. So there's 2 ways of doing this. I'm going to do it the first way, and then I'll explain the second way. The first way is we can take into consideration the fact that she pays $10. So if she pays $10 and she gets a white, she gets no money back. So technically, by getting white, she's losing $10 because she gave $10 and she doesn't get anything back. So this would be -10 for the outcome. while she would get K for a black. Now remember, she would get K dollars, but she still paid $10. So the outcome would be whatever they give her minus the $10. So these would be two outcomes for the black and white. If we know that our game is fair, then we know that the expected value should add up to 0. So in our calculators, we could do 0.4, the probability, times k minus 10 plus 0.6 times negative 10. And since this game is fair, we would need to add this up and make it equal to 0. So this is one equation you can put in your calculator to find out what is your expected value, remembering that k should always be represented as x in your calculators. Now, the second way that you could think about this question is you kind of forget the fact that they pay 10 to start with, and you just think about the outcome. Okay, so if she is running white, she gets $0, and if she gets black, she gets K dollars. And then the expected value for this one would be 0.4 times K plus 0.6 times 0. And now this should be equal not to 0, but how much she's paying. So this should be equal to 10. So two different ways to think about this, but we always need to consider how much they're paying to start with. In both cases, you simply put this into your calculator as numeric solve, and they're going to give you the exact same outcome. So with the second equation, our outcome is going to be x is equal to 25. And with the first equation, you are going to get the k value is also equal to 25. Okay. And the last example for today, given the probability density distribution shown in the table below, and the fact that the expected value is equal to 2.5, what is K, what is P, and what is Q? Okay, so for this question, we have two unknowns here. Every time we have two unknowns, we should be thinking simultaneous equations, right? Two unknowns, two equations. Okay, well, the first equation we can think about is the fact that our probabilities always need to add up to 1. So if I add up 0.2 plus p plus q plus 0.2, that needs to add up to 1. Next, we can use the expected value. Since the expected value is 2.5, that means that multiplying my outcome by its probability and adding all of these together should be equal to 2.5. So we have the two equations. So we have all the probabilities added up together equaling 1, and then we have our expected value equaling 2.5. In order to put this into your calculator, you're going to go on apps and you're going to scroll up or down to the 9th option, which is Polysim 2. And here you're going to see many options. We want to do the second one, which is simultaneous equation solver. We have, in fact, two equations, two unknowns. The rest of the information is asking if you want your answer in decimal or in scientific notation, and then degrees or radian, we don't really need that for now because we're not doing trigonometry. And then we click on next. Now notice that in here the equations are written in a specific way, where you have the x and the y is equal, and then you have the numbers. So you need to play around with your equations a little bit so that only the p and the q are on one side and all the numbers are on the other side. So for our first equation, we would have p plus q is equal to 1 minus 0.2 minus 0.2. Now, you don't need to do this full calculation beforehand. In your calculator, you can go and put in 1 minus 0.2 minus 0.2, and it's going to do that calculation for you. And then you need to repeat the same thing with the next equation. So for the next equation, we're going to be subtracting 0.2 and 4 times 0.2, so 0.8 on both sides. So with your second equation, you have here 2x plus 3y, and then the next number is going to be your 2.5 minus 0.2 minus 0.8. And then when you have your equations written, you click on solve, which is the graph button here. And then you see your answers for x and y, which represents p and q. If you want to have them in a decimal form, then you see the button F to D. You can click on this button here, and it's going to give you as a decimal.